All right, so now let us look at an example whereby we will have to identify forces, and we'd have to calculate forces if required or where possible, and then we represent these forces in a free body diagram. So those three steps. So just for recap, so you need to identify forces using keywords, right? And then also the direction. You have to know the direction of the forces. Weight, if we can do a recap. On the last lesson, we said that gravitational force is always acting downwards, right? So that is your direction. And the key term for your gravitational force is the mass, okay? And then your key term for the normal force is surface, right? Or a plane. And then the key term for frictional force is a rough surface, okay? And then for applied force, your key term is applied. Actually, they will tell you that the force is applied. And then for your tension, your key term is string or a rope, right? So let us look at this example here and identify all the forces that are acting on the object, and then also we have to draw a free body diagram. So in that free body diagram would be representing all the forces that are acting on that object. So with a free body diagram, I'll have my dot, and then I'll represent all my forces on this dot, okay? Or starting from that dot. So now let us read the statement and then try to identify the key terms that we use to identify the forces, okay? So the statement says a 12 kg block. So now we have already seen that we have mass, which is 12 kg, okay? So they don't specifically have to say mass, but you can see that 12 kg, that is mass. So if you have mass, then it means that you have your gravitational force according to the key terms, right? And your gravitational force is Fg equals to mg in terms of calculation. That is your formula. And then that would be Fg equals to your 12 kg multiplied by 9.8, and that would give you 117.6 newtons, and direction is always downwards, okay? So now we have identified that we have gravitational force, we have calculated gravitational force. Now we have to represent that gravitational force on the free body diagram. So that is your gravitational force, which is Fg going downwards, okay? So let us continue with the statement. So it says a 12 kg block is initially at rest, okay? So meaning that the object is not moving at that point, at point A, which is this point A here. So the object is not moving at point A. At the bottom of a rough inclined plane. So let us analyze this rough, okay, and plane. So it's a rough inclined plane. So now the first force that we can identify with this key term rough is friction. So now we know that we have friction, okay? And since we have friction, yes, it means that the surface is rough, right? But they said on an inclined plane. So the fact that we have a plane, it shows that we also have another force, which is normal force because there is a surface in this case. And you can see from the diagram that you have that surface which is an incline from A to B. That is an inclined surface, so meaning that you have normal force because you have a surface, and they also specified that that surface is rough, so it means you also have friction. Okay, so now we have identified two forces using those two key terms. So now the block is pulled up the incline, so meaning that this block is moving up the incline, it's moving from A to B, right? So we can actually get the direction of the frictional force. So the direction of the frictional force would be opposite the motion. So if the motion is moving in that direction, then we expect friction to move in that direction, which is the opposite direction of the motion. So we expect friction to move in that direction, or to point in that direction. And since the object is moving, the type of friction that we have is kinetic friction. Okay. And then in terms of the normal force always acts perpendicular to the surface. So we expect our normal force to act in that direction. So on our free body diagram, we expect the normal force to act in that direction. Okay. So we have identified three forces already. At 12 kg, we have mass, we have identified gravitational force. Initially at rest at point A at the bottom of a rough, then it means there is friction. Okay. And inclined plane, the fact there is a plane or there is a surface, we have normal force also. And then they continue to say the block is pulled up, then it means that if the block is moving upward, then now it gives us the direction of the friction, that the friction will move down the incline. Okay, so it is pulled up by a constant force. So this constant force is an applied force actually. So we can see on that object that we have an applied force of F, okay, which is acting parallel to the incline. So parallel to the incline is actually in that direction. So that is your applied force, and that is your friction, normal force, and then Fg. Okay, so let's continue with the statement. The block reaches point B, which is vertical height of 4.5 above the horizontal with the speed of 2.25 meters per second. See the diagram below. So in terms of identifying the forces, we have identified all the forces that are acting on the object. Force number 1, we identified that we have gravitational force. Then force number 2, we identified that we have friction because there is a rough surface. Force number 3, we have identified that there is normal force because there is a surface. And sometimes you can see from the diagram that there is a surface, then you already know that there is normal force. But for you to identify whether there is friction, you need to check whether this surface is rough or not rough. Okay. And then we were also given a constant force, which is an applied force in this case. And then we represented all these forces in a free body diagram. So this is the outcome actually for this video. You had to identify the forces and then represent them on a free body diagram. So this is how we identify using the key terms.